Good morning. So nice to see you again. So today we're going to take a look at the third, count 'em three, the third equation for linear relations. And that's called the slope-point form of the equation of a line. So just to review, we've looked at the slope y-intercept form, which you can't see. Now you can see it. The slope y-intercept form, y equals mx plus b, which tells you, remember, the slope. And I bet you can't see that. And the y-intercept. Okay? Well, you can almost see it. The second one we looked at was the general form, which is ax plus by plus c equals 0. And remember, for that one, the numbers are whole numbers. The number attached to x has to be positive. Okay, so remember, we did some stuff with multiplying through by a common denominator or a negative sign, just to make sure that we had positive numbers in front of everything. Okay? Today, we're going to take a look at the third form, the slope-point form, which is just a rearrangement of your slope formula, which is right here. Remember, slope m equals y2 minus y1 over x2 minus x1. Now, if we rearrange this formula by getting rid of the denominator, remember, to get rid of the denominator, you would just multiply both sides by the thing you're trying to get rid of, which in this case is x2 minus x1. What this ends up being is, you can see that the x2 minus x1s will cancel. So you're left with y2 minus y1 on the right side, and slope times x2 minus x1. Okay? Now, if that went right over your head, don't worry about it. You've got the formula on your formula sheet. If you don't have your formula sheet with you at home, you should. I will post a copy of the formula sheet to Google Classroom. Okay? But this is the third formula. We put brackets around the y2 minus y1 and the x2 minus x1. Remember, m is the slope. So the slope point formula also uses the slope. And then we use any point on the line as our x1 and our y1 to give us an equation for the line. Okay? So for instance, for this first example here, it says determine the equation of a line that has a slope of 5, so they've given us a value for m, and passes through the point P at 3 and 4. That is our x1 and y1 values. So they've actually given us a whole lot of stuff, which we can then plug into our formula, which is y2 minus y1 equals slope times x2 minus x1. Okay? Now again, remember, they've given us the slope. So where you see m, you can sub in the slope. And they've also given us values for y1, it's 4, and x1, it's 3. So this becomes y2 minus 4 equals 5 times x2 minus our x1 value, which in this case is 3. Now, typically, once we've plugged in values for our x1 and y1, we don't bother with these subscripts anymore because we don't have to tell the difference between two y's or two x's. Okay? So, here's our point slope formula. Now, this point slope formula can be rearranged to either of our other two formulas, to our standard or general form, or to y equals mx plus b, simply by either isolating y to get y equals mx plus b, or simplifying and moving everything to one side. That will give us our general form. And we'll do some of those today in the lesson. Okay? So, we're done for the first one. We've plugged in our slope, we've plugged in our y1, we've plugged in our x1. One thing I want you to be aware of is when plugged into the formula, you will always have the opposite sign of the coordinate that you started with. So if you start with a positive 3, it ends up being minus 3. If you start with a positive 4, it ends up being minus 4. Okay? So just be aware of that because there will be problems where typically students make the mistake of saying, oh, this coordinate would be negative 4 and this coordinate would be negative 3. Okay, just remember the sign changes when you plug it in. So this equation is called the slope point form for the equation of the line. Both the slope and the coordinates of a point can be identified from the equation. So again, it says the line at right has a slope m and passes through the point P, x1, y1. Another point on the line is Q, xy. Okay? And again, just a reminder, you can use the slope point formula to develop from this your formula, right? Where your slope is m, your x and y1 are the coordinates of point P, your x and y2 are the coordinates of point Q. Okay? And here's our slope point formula. Okay? So let's just practice a little bit with this. It says, given the slope of the line and a point on the line, so again, remember the name of it tells you what you need to use that formula. It's called the slope point form, so if you have the slope and you have a point, you can use it. Okay? So, determine the equation of each line using slope point form. Then express each equation in slope-intercept and general form. So in other words, we're going to have some practice now rearranging from our slope point form of the equation to our slope-intercept form, y equals mx plus b, and to our standard form, ax plus by plus c equals 0. And by the way, I have a bad habit of calling it standard form. That's just another name for general form. I'll try and avoid that. Okay, so we have our slope, we have our point, so we can use slope point form. So our slope point form, remember, is y2 minus y1 equals the slope times x2 minus x1. Plug in our known values. We know that the slope is negative 3. We know the value of our x1 is minus 2. And so when we plug that in as minus 2, you'll notice what happens. You have minus a negative, which is more simply written as plus. Okay? So remember, when you subtract a negative number, it's easier to simply write it as an addition. On this side, our y2 minus y1 becomes y minus, there's our y value, 7. So now we have our equation in slope point form. To rearrange it into slope-intercept form, we simplify both sides as much as we can, and then we isolate y. Because remember, slope-intercept form has y all by itself on one side and everything else on the other side. So let's do that. So first let's simplify. Well, there's no simplifying that you can do on the left side. We'll just drop the brackets and it becomes y minus 7. On the right side, we can simplify. We can distribute the slope over both of these values. Minus 3 times x is minus 3x. Minus 3 times 2 is minus 6. Okay? So we've simplified the right side. The last thing we have to do, if we want it in slope-intercept form, is to isolate y. And that's easy. We only have one thing to get rid of here. We have to get rid of this minus 7. So we'll add 7 to both sides. Minus 7 plus 7 is 0. That leaves us with y. That's what we want, right? We want y by itself. Minus 6 plus 7 is plus 1. Okay? So what does that tell us? Remember, the slope-intercept form is nice because it tells us not only the slope will be negative 3, which you'll notice we already knew, so that gives us an indication that we've simplified everything correctly, right? That slope value hasn't changed. And our y-intercept, that is the place where the line crosses the y-axis, is at 0 and 1, right? The y-intercept is 1. Now, we're halfway done. They wanted us to put it in slope-intercept form. We've done that, ka-ching. And now they want it in general form. So now we're going to take our equation of the line in slope-intercept form, and we're going to put it in general form, which, remember, simply means we move everything to one side and then we check the numbers. Okay, so let's move everything to one side. Well, that's easy. We just have to get rid of the y. So we'll subtract y from both sides. Y minus y will give us 0, right? They cancel. And then, since there are no like terms that we can combine with minus y, we just rewrite it as minus 3x minus y plus 1. Now we've done the first part of converting to general form. Now we have to check for the second part, do we have all whole numbers and do we have a positive coefficient of x, that is a positive number attached to the x? Well, we don't have any fractions or decimals, that's good, but we do have to get rid of this negative. And remember, that's easy. From previous lessons, you know that to get rid of a negative sign, all you have to do is multiply the equation through by negative 1. So we're going to distribute this negative 1 over everything inside the brackets. Negative 1 times 0 is 0. Negative 1 times negative 3 is positive 3x. Negative 1 times minus y is plus y. Negative 1 times positive 1 is minus 1. Look at us. We're done. Okay, so we've put it in slope-intercept form, we've put it in general form, and there's our original slope point form. So again, as I said at the beginning of the lesson, the idea of today's lesson is this ability to switch from one form to the other of your three forms of the equation of a line. Okay? We're going to skip this one, and we're going to move on and do some of these ones which involve graphs. Okay? So, this says, write an equation in slope point form of each line passing through the given point. Okay? So, for our first line, we have a point right here. Okay? It's at 3 across and 1 up. So, for slope point form, we got the point. What we don't got is the slope. So we're going to have to find what the slope is, and you can do that. We've been doing that for a long time now. If you have 2 points on the line, you can find the slope. And they've kind of led us along nicely with this dashed line to say, hey buddy, use that point to find the slope. So, what are the coordinates of this point? 4 across and 5 up. If we have 2 points on the line, we can find the slope. So let's plug these into the slope formula. Remember that's slope equals y2 minus y1 over x2 minus x1. Plug in your values. y2 minus y1 becomes 5 minus 1. x2 minus x1 becomes 4 minus 3. Okay, so 5 minus 1 divided by 4 minus 3 gives us 4 over 1, or simply 4. Okay, so now that we have the slope and we have a point, we can write our equation in slope-point form. Now, slope-point form simply requires any one point on the line. So it doesn't matter if we use this one or this one, we'll get an equation. Now, this may cause you some fear, but there are different forms of the slope-point equation of a line. In other words, we can write an equation in slope-point form using this point. It would become y minus y1, right? There's our y value, equals the slope, in this case 4, times x minus x1. This would be a perfectly reasonable answer, and you would get the big check mark. Okay? However, we could also use this point, and it would become, so we'll say, or y2 minus our y1 minus 5 equals our slope. That's going to stay the same. And x minus our x1 value, 4. So you can see that in this case we're using the point 3,1. In this case we're using the point 4,5. The slope stays the same. Either of these is correct. Okay? You could use any point on this line to plug into your slope point formula. So there are an infinite number of equations that will work. So slope point form, there are an infinite number of equations that you could get depending on the point you plug in. Okay? Don't worry too much about that. When you rearrange it into general form or y equals mx plus b, they will all look the same. Okay? So we'll do another example of this. So what we have here is we simply have, just let me get rid of some of this junk. We'll get rid of this. What we have here is simply, in word form, what we had in the last question. In other words, in the last question, we had a graphed line. We could easily find 2 points on the line. We plugged them into our slope formula, and we got our slope point formula. The only difference with this next question is we haven't been given a graph, but we've still been given our 2 points. Okay? So our points are 2, -1, and 4, 2. First step, use your 2 points to find the slope. So, in this case, our y2 minus y1 would be 2 minus -1. Our x2 minus x1 then become 4 minus 2. Okay? So, y2 minus y1 divided by x2 minus x1. And what does that give us? Well, 2 minus -1 is like saying 2 plus 1, or 3. 4 minus 2 is 2. So in this case, we have a fractional slope. No big deal. Okay? Plug it into our slope point form. Remember, that's y2 minus y1 equals slope times x2 minus x1. remember we only use one point and the slope. So we can use either this point, 2, -1, and plug that in, or we can use this point, 4, 2, and plug that in. I'm going to pick 2, -1. So this becomes y minus our y value, which is -1, equals our slope, which we just found out, it's 3/2, times x minus our x1 value, which in this case is 2. Okay? So we plugged in the slope, we plugged in the coordinates of either one of the points. It doesn't matter which of these we use. Okay? Now, it's asked you to rewrite the equation in general form. So again, step 1, simplify this side of the equation. Step 2, put it into general form. So we're going to simplify. Y minus -1 is more simply written as y plus 1. For this one, remember we need to distribute this fraction over both. So 3/2 times x is 3/2x. 3/2 times -2 is minus 3 times 2 is 6/2. And that can more simply just be written as y plus 1 equals 3/2x. 6/2 will simplify to a whole number. Okay? Now, to put it in general form, remember, we have to move everything over to the other side. So, let's get rid of the 1 first. To get rid of the 1, we would just subtract 1 from both sides, leaving us with y equals 3/2 x plus 1 minus 1 cancels. -3 minus 1 is -4. So look, does this look familiar? This is your slope-intercept form. Okay? But they've asked us to put it into general form, so we're not done. We have to move this y over as well. Subtract y from both sides. I'm just going to write the answer up here. So y minus y gives us 0. This won't combine with either of these. It's not a like term, so we just write them out again. 3/2x minus y minus 4. Okay? We're not done yet. It's not in general form. Everything's been moved over to one side, so we've done the first part, but we've got a fraction here, and we've got to get rid of that fraction. Okay? It's a positive fraction, so we don't have to multiply by -1. We do, however, have to get rid of that denominator, and remember, to do that, we simply multiply everything through by our denominator. So 2 times 0, 2 times 3/2, 2 times -1, 2 times -4. So 2 times 0 is 0. 2 times 3 will give us 6/2x. 2 times -1 will give us -2y. 2 times -4 will give us -8. And then, and it's the reason we do this, our new fraction will simplify to a whole number. It'll simplify to 3x minus 2y minus 8. All the numbers are integers. The number attached to x is positive. This is general form. So we're done. Moving right along. Okay, we're not going to do this one because it's exactly the same as the others we've done. But again, just a nice review of what we've been doing. Remember, if you're given 2 points, the first thing you have to do is calculate the slope, which remember is what we did as our first thing here. And then once you know that, substitute either one of the points, so either this one or this one, doesn't matter, and your slope that you just figured out into your slope point form. Okay? So, why don't we do Number 1 says, determine the equation of a line in slope point form given the following information about the line. Convert each equation to general form. Now, when you first read this, you might say to yourself, what the heck? I don't have enough information. They haven't given me the coordinates of a point. Well, guess again. They have given you the coordinates of a point. When they tell you the x-intercept is -4, remember what that means. That means you have an equation, and that equation crosses the x-axis. Let's back that up. I didn't see that it was a -4. That means it crosses the x-axis at -4. Okay? So, when they tell you this, they're also telling you the coordinates of a point, right? Because the coordinates of the x-intercept, if the x-intercept is -4, the coordinates are -4 and 0. Remember, all points on the x-axis will have a y-coordinate of 0. Okay? So what they're really saying is, here is the point for you to use. Okay? So we have a slope of 2, an x-intercept of -4. Plug that into your slope point form. y2 minus y1 equals the slope times x2 minus x1. Your slope is -4. Your x value is also -4, so this becomes x plus 4. Remember, minus -4 is like saying plus 4. Over here, we have y minus our y value, which is 0. That's handy because it's just going to disappear, right? So, simplify both sides. Y minus 0 is just more simply written as y. Distribute this -4 over both of these terms inside the brackets. -4 times x is -4x. -4 times 4 is -16. Make sense? Good. Okay. Something, let's just make sure. Oh. No, that's right. Just let me check this thing here. So this is -4, 0. So that makes that plus 4. That's what I did. I'm so sorry. Let's back up. I didn't put the right slope in. I'm sorry. The slope here is 2. That means when you multiply across, that will give you 2x and 8. Okay? Sorry about that. So, again, 2 times x is 2x, 2 times 4 is 8. Now we have to put this in general form. Easy. We just have to move everything over to one side, so we're going to subtract y from both sides. Y minus y is 0, and this side becomes 2x minus y plus 8. Check and make sure it's really in general form. They're all integers, right? We have +2, -1, and 8. The coefficient of x, the number attached to x, is positive, so we're done. This is our general form for this line. Okay? How are we doing for time? Okay. So why don't we try this one? So C. Because in our next lesson, this is what's going to give you guys a lot of grief, right? There are many different ways to extract information about a line, and you need to be able to recognize those many different ways. So, in the case of this one, it says the line we're looking for has the same slope as this line. They haven't been nice and just said the slope of the line is blah, blah, blah. They've said this line here, which we're not really interested in, has the same slope as the line we are interested in. Well, what is the slope of this line? All you have to do is look and see. See, this is in slope-intercept form. All you have to do is look and see what number is attached to x. So, the slope in this case is the number attached to x. Remember, y equals mx plus b. Now we have the slope, we have a point, we can plug them into our slope point formula. y2 minus y1 equals the slope times x2 minus x1. Our slope is -2, so that goes there. Our x value is 1, so it becomes x minus 1. Our y value is -3, so it becomes y plus 3. Again, remember, minus -3 is plus 3. Okay? So here's our slope point form. Remember, they've asked us to put it in general form. So simplify both sides. The left side is already as simplified as it can be. The right side, we have to distribute -2 over both of these. That gives us y plus 3 equals -2x. -2 minus -1 becomes plus 2. Okay? Now, to put it into general form, remember, we have to move everything over to one side and then deal with the numbers. So, we'll subtract 3 from both sides. So -3 minus 3 cancels on this side, leaving us with y on the left and minus 2x, and then plus 2 minus 3 gives us -1. Okay? Since we're going for general form, we have to move the y as well. We have to move everything over. So we'll take away y from both sides. Y minus y gives us 0. And on the right side, we have -2x minus y minus 1. So, no fractions, no decimals. That's good. We don't have to deal with those. However, the number attached to x is negative. So our last step, multiply through by -1. -1 times 0 will give us 0. -1 times -2 will give us plus 2x. -1 times -1 will give us plus y. -1 times -1 will give us plus 1. And there's your answer. Okay? So, 0 equals 2x plus y plus 1. So we'll do one of these. Oh, this is going to be a long lesson. Sorry, guys. So it says identify the slope and a point on each line, sketch a graph. So remember, the nice thing about slope point form is it gives you that information just by looking. Our slope is the number in front of the bracketed x expression. Our slope is 3. The point on the line, remember, is just these values here. And remember, they'll always have the opposite sign. So our x value will be +2, our y value will be +1. That gives us enough information to sketch our line. Okay? So we know that one point on the line is at 2 across and 1 up. Okay? So 2 and 1. And we know our slope, and I'm just going to write it as a fraction. Our slope gives us directions to get to a second point. Our change in y is on top, so we'll just write that. Our change in x is on the bottom, and what that means in this case is, since the 3 is positive, we're going to go 3 to the right. And our change in x is, I do that all the time. Be careful, don't be like me. So our change in y means you're going to go 3 up. Our change in x means you're going to go 1 to the right. So both positive directions, positive in the x, positive in the y. So from this point, we go 3 up, 1, 2, 3. We go 1 right. That gives us our second point. And by joining the points, we sketch our line. Okay? Good, good? Now, word problems. We'll just do the first one. So, this says, 2 hours after a candle is lit, it is 16 centimeters tall. 6.5 hours after the candle is lit, it is 4.75 centimeters tall. Sketch a line showing the relationship between hours lit and height. So again, here are your variables. Anytime you have time as a variable, it goes on the bottom. So we have time in hours. Okay? Our other variable is the height. Make sure you include the units, centimeters. So, it says 2 hours after a candle is lit, it is 16 centimeters tall. So, at a time of 0 hours, that candle's going to be taller, right? Because they're telling you it's been burning for 2 hours and it's 16 centimeters tall. So the reason I say that is you want to take that into consideration when you set your scale, your heights. So let's say we'll take it up to 24, okay? So we'll say halfway up is 12, 6, 18, 24. Okay? So, here are our hours. Notice we're going up by the same amount each time. We're going up by 6. Okay? Sorry, our heights. For our hours, let's just say we'll make it 10 hours. Okay? So again, we have 5, 2, 2, 4, 6, 2, 4, 6, 8, 10. Okay, we don't have a grid, so this is an approximation. Okay, so they're telling you at 2 hours, we have a height of 16 centimeters. So there's our first point, 2 across and 16, which would be about here. Okay, so 2 and 16. And then at 6.5 hours, it's 4.75. So at 6.5 hours, which would be about here, it's 4.75, which would probably be about here. So 6.5, 4.75 are our time and our height. We have 2 points. So, if we've got our 2 points plotted, all we have to do is join them. And there's our line. Okay? Write a linear equation in general form representing this scenario. So, remember, for any of our equations, we need to find the slope. So that's going to be your first step. Okay, so find the slope. Slope equals y2 minus y1 over x2 minus x1. I'm just going to go this way. Our y2 and y1 are 16 and 4.75, so 16 minus 4.75. Our x2 minus x1 then becomes 2 minus 6.5, which gives us 16 minus 4.75 is 11.25. 2 minus 6.5 gives us, this is an ugly problem, 2 minus 6.5 equals negative 4.5. Okay? So there's our slope. State the slope of the line. What does it represent? So the slope is 11.25 over negative 4.5. What does it represent? Well, look to the units. Your y is centimeters, your x is hours. So it's giving you the rate of, you can think of it as the rate of burning or the rate of decrease in height. In any event, the candle is shrinking, right? It's burning and it's getting smaller and smaller. And it's getting smaller and smaller at a rate of 11.25 centimeters per hour. Okay? Let's just see if we can simplify that fraction at all. So 11.25 over 4.5. It simplifies fairly nicely to 2.5 centimeters per hour. And because our slope is negative, that's what tells us we're dealing with a decrease, something that's getting smaller. Okay? Determine the y-intercept. What does it represent? Well, remember there's a number of different ways we can find the y-intercept here. Okay? But the way I'm going to do it is I'm going to use our slope-intercept formula. So if we take, I'm running out of room here, if we take our slope-intercept form, which is y equals mx plus b, we have enough information to find the y-intercept, right? Because we know what the slope is. It's a negative 2.5. And we also have a value for x and y, right? We'll use this one because it has whole numbers. We could just as easily have used the other point. But we know that one point on the line has an x-coordinate of 2 and a y-coordinate of 16. So where we see y, we'll plug in 16. Where we see x, we'll plug in 2. And then we only have one unknown, the y-intercept. So we can simplify our equation, and that will give us the y-intercept. So let's simplify. 16 equals negative 2.5 times 2 is negative 5 plus b. To isolate b, we simply add 5 to both sides, and we get 21 equals b. What does that represent? Well, remember, we had a line that looked like, this. What the y-intercept represents at 21 is, so the y-intercept is 21. What does it represent? The height at the start. Okay? So just as you lit the candle, it would have been 21 centimeters high. After 2 hours, it would have been 16 centimeters high. And then after 6.5 hours, it would have been even smaller, right? It would have been 4.75 centimeters high. So the y-intercept represents the height of the candle at the very beginning. Okay? Tomorrow we'll do some of the actual practice questions from your assignment booklet. This is 7.3 for your assignment booklet, and hopefully that will help you a little bit more. Anyways, it's been fun as always. See ya.